Well, remember yesterday we had people writing in and ringing in about the mathematical equation of you've got to stay 1.5 meters from people, but if you're in a venue, it's 4 square metres. It was all kicked off by Lee, one of our listeners who wrote in saying, okay, what's the maths of the 1.5 metre separation and the 4 square metres? And he came up with an equation that said it was 2.25 square metres, not 4 metres. We had all sorts of people ringing in, but we thought we would go to an absolute expert, Associate Professor Yoni Nazarathy. He's from the University of Queensland's School of Maths and Physics. He's heavily involved also in the COVID Safe Blues contact tracing program, so he knows all about the health regulations which are also a factor in these equations. So he's come along to help. Good morning, Associate Professor.
Hi, good morning.
Now, first to the maths. So, okay, you talk me through it. So I've got to stay 1.5 metres away from someone, but if I'm in a venue, I need my own 4 square metres of space. Does 1.5 square metres being away from someone equal 4 square metres in a venue?
Yeah, so 1.5 meters away from somebody. Well, we need to stay away from people in general. Unfortunately, physically away, not emotionally away. And that's, of course, because we spread droplets, right? And breathe and can potentially spread the virus. 1.5 meters, that's not square meters, that's meters, is a general guideline for distance. Now, if we're putting people in a room, in a space, then by having not more than one person for an area of 4 square meters, we're actually allowing an average of about 1.5 meters per person. Now, of course, this varies, right? People are not chairs. We don't place them statically in a room and they don't move, right? People are dynamic. Now, if you want to actually see the relationship, which is not an exact relationship between the 4 square meters and the 1.5 meters,
yes,
one thing you can do is look at a tiled floor. So for those of you that have a tiled floor in your house, or just imagine tiles, look at the tiles. And if you look at a tile, just imagine that a tile is 2 meters by 2 meters, right? Tiles
yes,
are not. Your tiles are much shorter. Maybe they're
yes,
40 centimeters by 40, etc. But imagine a 2 meter by 2 meter tile. So the area of that tile is 4 square meters. Now put a few of these tiles together, okay? And imagine that a person is in each of these tiles, okay? So that is in general the guideline. Now when you have people standing in the middle of these tiles, they will actually be 2 meters away from each other.
correct,
1 meter in each direction.
correct.
But allow them to move a bit to the right, a bit to the left, etc.
They'll get a bit closer.
Exactly, and very, very, very quickly they can be closer than 2 meters, and about 1.5 meters. So people are dynamic, luckily.
Right.
So the guideline is kind of a sensible guideline. I mean, the alternative would be maybe a person every 1 square meter. That would be too close, right?
Yeah.
So it would be a person every 3 square meters. That would also be, not the right number. So then 4 square meters is just a sensible guideline considering how people move. But it's just an approximation.
Well, you took me back to Maths 1 in 1985 and the Lockie block at State High there. Mr. Schlierhoff was my teacher, and he didn't teach me as well as that. Can you just quickly tell me about the COVID Safe Blues initiative, which is where you're contact tracing COVID-19?
Yeah, sure. Well, thanks for asking. So there are actually 2 different things. So, of course, there's the Australian contact tracing app that is, in fact, almost a replica of the Singaporean contact tracing app, and that's called COVID Safe. And I hope that many of us have this running on our phone. What it does contact tracing. That's not the thing that I'm involved with, but let me just say a word about COVID Safe first. So the way that contact tracing works is, we run with this app on a cellular device.
Yes.
And when we're near other people, it records the proximity of those other people based on Bluetooth signals. Should there be the unfortunate situation where we are then diagnosed with COVID, then we have the ability to reveal...
Find who we were near.
Yeah. And then they're contact traced.
Yeah.
So that helps the many great professionals and the contact tracers actually do their job. Now, the project that I was am heavily involved with, that's together with other researchers from the University of Melbourne and from MIT in the United States and Cornell in the United States, is a project called Safe Blues. And this is still an experimental project, but it is something that is somewhat related to contact tracing, but it's not.
Yeah.
It's about simulating how the virus spreads by using the dynamics of the population, by using movements of the population, and then learning, what's happening with COVID, and that's using machine learning and artificial intelligence and statistics. So I'll just state the general idea very, very quickly. I
haven't got much time. You have to get through it real quick.
Okay, so you got it in 15 seconds. So the general idea is if you could spread a real virus that is just like COVID, but is not, and measure it in real time, that'd be great. You'd give it to the whole population, and if that virus would be safe, a biological virus, and you'd see, this is how this thing is spreading. People are going to important demonstrations. This is how it's spreading. People are touching each other, not touching each other. This is how it's spreading. But you can't. So what you do is you do a virtual safe virus-like token on a cellular phone, and you count these things. So that's the general idea. More information is on our website. That's safeblues.org.
Safeblues.org. Sounds like terrific work, Professor Yoni Nazarathy. He used the tiles so we could work out the equation, and 4 square metres is 1.5 metres, and it works out perfectly. Thanks so much for joining us on 4BC Breakfast. It's 20 minutes after 6.